Engineers of the Boeing Company and the National Aeronautics and Space Administration are making final preparations to launch one of a series of lunar orbiters. The satellite's primary mission is to photograph landing areas on the moon for America's astronauts. Atlas Agena booster will launch the orbiter from Cape Kennedy. Their precise information of the effects of the moon's gravitational field on the spacecraft. With this knowledge, they will be able to lower the vehicle's orbit to a close 28 miles topography of the moon's surface. Control of the spacecraft is accomplished through instructions stored in an onboard computer. Mission control personnel can radio new instructions from storage or can bypass the computer to control the orbiter directly. Operating on these instructions, the lunar orbiter will turn itself to aim its two camera lenses downward during picture-taking orbits. Then, as it soars over the desired areas, it will take a series of pictures. One lens will cover an area of 25 square miles and record objects as small as a card table. The other will make overlapping photographs of 440 square mile sections. During its mission, the lunar orbiter will take 160 pairs of pictures while filming 12,000 square miles, area as large as the combined area of Massachusetts and Connecticut. While photography is in progress, the camera will begin to automatically develop and store the exposed film. Following each series of exposures, the orbiter will again aim its solar panels at the sun. When picture transmission takes place, the stored images will be sent in the form of an electronic signal produced by a light scanning the stored negatives. At Goldstone, near an abandoned gold mine in California's Mojave Desert, this 85-foot diameter antenna is the communication link orbiter. It's similar to two other antennas in Australia and Spain, surrounding hills protected from random radio signals. The antenna control team tracks the orbiter with signals the orbiter sends back to Earth. The team also directs the flow of signals from the end to the orbiter. This equipment generates signals to the spacecraft. The orbiter's computer responds to the signals, controls the orbiter accordingly. These men are the last human link between Earth and the spacecraft. Incoming photographic information from the orbiter is shows what the orbiter's camera saw. At the receiving station, technicians will process and study samples of exposed negatives, ensure that signals are coming back properly, and that the orbiter's camera is correctly set. Most of the 18 miles of film will be sent to a reassembly facility. Script will be developed and arranged into large negatives. Prints of these negatives will form the basis for lunar maps. Although direct communication with the Lunar Orbiter is via Goldstone, or Australia, or Spain, the mission is directed from the Spaceflight Operations Facility in Pasadena. Sitting side by side, NASA and Boeing engineers evaluate and act upon information received from the antennas.